to come and attend. So I am, as ma'am mentioned, an AI specialist and architect at Jogit. And I started off with kind of web automation, then I moved on to NLP, computer vision, and finally my journey has brought me down to LLMs, which is um, very popular these days. So the aim of this presentation is to not get into too much technical nitty-gritties, but to give you guys an idea of where to start, right? So I will be unraveling ChatGPT, how it works, how you can do something with it or something like that. And then kind of, discuss these ideas as we move along, both for LLMs and LFMs. LFMs stand basically for large foundation models. Um, and in case you guys want to discuss any of these ideas in detail with me, I have my email right here. So feel free to email me right after this seminar or whenever you feel is comfortable. All right. So one moment. Okay. So ChatGPT was launched on December 4th, 2022, and it took it only 5 days to kind of gain 1 million views. Right? Because that is the impact that it had on all of us. You can go and ask it questions and it would give you with answers for any topic that you want to talk about, right? Uh, but you could argue that, threads from Instagram took only 1 day to gain 1 million followers, but that is not something that, really reimagined how we interact with it. It was kind of a clone of Twitter, right? So that is why ChatGPT is still the fastest one to gain 1 million users. In case you have not experienced ChatGPT yet, you can access it on chat.openai.com. This is how the interface looks like, and you can get questions, whatever topic you want. You can even take its help in writing emails and blogs and whatnot, right? So, for example, I asked it,
Anchit, I'm so sorry to interrupt. Are you sharing some screen?
I am, ma'am. Is it not visible?
It is not visible to me. I'm not sure about others.
Oh, God. Okay.
No, ma'am, the screen is
Not
not visible.
visible to us also, ma'am.
It is
Okay.
Uh,
Okay.
uh,
Okay.
Let me just reshare it and I will start again.
No, I think you can continue from here only, but you can share your screen.
One moment.
Yes, Anchit, now we can see your screen.
Okay, awesome. Not sure what the thing was, but chalo, it is what it is, right?
No worries. Yeah.
Okay. In case you want to note down my email, I'll just go to the first slide. This is my email in case you want to email me now. And sorry, do you have a question? Okay.
Priyanka, please try to mute those who who are unmuting themselves now. If guys, if you have any question, you can unmute. Otherwise, please keep mute.
Yeah, thank you, ma'am. Okay. So you can just note down my email and kind of ask any questions that you want. I'll continue from this slide. This is how the ChatGPT interface looks like. I'm sure that you are aware of it. But for those who have not yet experienced it, I suggest that you go and create your account and start asking questions. It is a great study buddy. Okay. Priyanka ma'am, can you please mute? Thank you. So in this, I asked a question. Can we say that knowledge graph is a type of database, which is a technical question, and ChatGPT was very nicely able to explain all of it. And you can even ask it questions related to your code, right? So I gave it a string, like a piece of my code, and I wanted to ask it to do substring searching in Mongo. This is kind of a regex function that I wrote, and it gave me an example and how I can actually do it. So it can even help you with debugging and writing code for any of the new projects that you're working on. But if you search when was GPT released, so ChatGPT's core architecture like model is GPT-3. It was released on 11th June 2020. So what took it so long to kind of adapt into ChatGPT and opening it to so many users? The answer is pretty simple, that base models are not assistants. So on the left hand side, I have a base model and its output. And on the right hand side, I have kind of, how we can trick that model. So if you see that I asked it, can you write a poem about bread and cheese? And the way it answers is that it gives me more questions that I don't want to answer it, but here are some more questions that you might like. Because these base models, these are trained to only complete text, right? They're not trained to follow instructions. So there is a difference between base models and instruction following models. But we can trick these base models. So for example, if I write here is a poem about bread and cheese, now since it is trained to complete text, it begins to complete all of that poem and give me all of the answers that I want. But the problem with this is that it is not really convenient for users, right? Because normal people who are not into these technical details, they will find it very hard to do this sort of prompt engineering. So what is the solution that we have? Before the solution, actually, I want to start with where it all began, right? So according to me, when it all started to change and, it really started to make a difference is with the release of GANs. So GANs is also sort of a generative AI model. And these are basically used to generate images. I have a very simple architecture of GAN in front of you. It is used to generate faces, right? So in GANs, we have a generator and we have a discriminator. And the task of generator is to generate faces. Discriminator is to discriminate between real faces and fake faces that are there. And of course, like generator is given a head start, else, discriminator will very quickly catch up. And these are getting like really, really good these days. And you can go to some website like this person does not exist, and it is really getting good. So applications of GANs are very cool. Like, for example, you can give it an image and you can reconstruct an image, like edit it. For example, this image was converted into a blonde with bangs, smile, and even into a male. And I think the most popular use case for GANs is when researchers and scientists used it to uh, detect fake Mona Lisa from the real Mona Lisa, right? Because the artist's paint brush strokes were captured and all of these things were done. And I think it is a pretty useful case. And in front of you, one image is generated by GANs and the other one is a real image. Can you quickly type in the chat box which one do you think is the real one, left or right? Okay, we've got one right, one left. And you can immediately start to see that there is a visible confusion in this, right? So some are saying right, some are saying left. I think the bias is towards left one is real, right? I think it's towards right now, maybe. Let's see. Well, the right one is the real one. Most of you said that the left one is real one, but in actuality, the right one is real one. And this game, it is like super cool. A couple of you might feel that it is very simple and we can easily discriminate between the one that is generated and the one that is real. But once you are 10 images down the lane, is there a question? Okay. Once you're 10-15 images down the lane in this game, I'm sure that you will get one of these images incorrect, right? There are some things that you can notice. For example, GANs are not really perfect. So if you see there are some, small details that you can capture to differentiate between the one that is generated and the one that is real one. So that is how GANs were used to detect fake Mona Lisa from the real Mona Lisa also. Using GANs, using the discriminator that was trained on the artist's images. Well, GANs then moved on to deepfakes, and in front of you, the left one is a deepfake video of this woman, and the right one is original one. And similarly, I have one of this is generated by deepfake, and the other one is real. Which one of these do you think is real, and which one of these do you think is fake? Again, left or right in the chat box. Okay, we've got one left, one right again. See, there is again a confusion, right? A couple of you are saying left is real, a couple of you are saying right is real, right? Okay, let's just see. Well, the one on the left is the original one, and the one on the right is deepfake. You can see how good these models are getting, right? And how difficult it is becoming to kind of differentiate between the ones that are generated and the ones that are original. And these raise some ethical concerns as well. For example, a lot of college students these days use ChatGPT to do their assignments, right? And professors are having a really hard time in discriminating, like who is the real person and who use ChatGPT to help with their assignments. Um, so generative AI is kind of a subset of artificial intelligence which deals with generation of anything. It could be images, it could be sounds, it could be text, anything. So I have here three models that really made a difference. On the leftmost side, I have DALE, which was released in 2021, and I gave it a prompt of a cow reading a newspaper in Paris, in front of Eiffel Tower. I don't know why, but it worked really well. It was able to capture all of these details in this text, and it generated a beautiful image, right? In the middle, there is style GAN. If you go to thispersondoesnotexist.com, it will generate a face for you, which does not exist in real life, right? So it is pretty cool. And not just person, you can go to this car.doesnotexist.com, and they have kind of list of all of the websites that there are, the GANs that they've trained. And NVIDIA has done this wonderful research on style GANs. And I think the architecture is open source and you can train it on your custom datasets also. On the rightmost side, I have WaveNet, which was released in 2016. This was not the first model to do this thing, but I feel that this is where, companies like Apple and Google, in their iOS and Android, really started to include these machine learning models with the release of WaveNet. Siri was released, right? Google Assistant was released. I think WaveNet was one of the crucial models that helped them do this. But this research has been going on for so long. If you see at the bottom, I have a research paper, The Generation of Sound by Turbulent and Separated Flows. It was published in December 1993. This was the first that I could find, but I'm sure that if you kind of go and try to find a research paper which was written even before this, I'm sure that you will find something um, about generation of sounds. So, the point is that research keeps going on, then these models keep on improving, right? All we can do is be a part of it and be aware of what is going around us so that we can make our lives easier. Uh, like ChatGPT has reduced my development time by half because now I can just go to ChatGPT and ask my doubts. Yep, sometime it hallucinates, and GPT-4 is getting better at it. And I think 2, 3 years down the lane, we'll really get there. So it's pretty exciting of what is there in front of us. So let's now talk about how GPT was made useful. A couple of slides back, we talked about how base models are not assistants, right? Which made OpenAI wait for 1.5 years, I believe, before releasing ChatGPT to make this base model an assistant. So let's now talk about how GPT was made useful. It is really a four-step process to train a large language model like this. First, we have pre-training. Now, the base model is a pre-trained model. So the one that I demoed was basically this pre-trained model. It is trained on raw internet, trillions of words, low quality and large quantity. All of the websites are parsed. Some open source data sets are there. And OpenAI kind of worked on parsing more websites which are not there in the open source data set. They worked on updating that data set, right? And the task for this model is just to predict the next token. For example, when you go to your keyboard and you start typing in, you get a couple of suggestions of what next you could type in, right? So it's kind of pretty similar. Like the task is to generate the next token. And this gives us a base model. Now, this is the costliest thing to do because it takes thousands of GPUs and months of training. And examples could be GPT, Llama, Palm, and even Bard. And when I say Llama, I do not mean Llama Instruct. And even for GPT, I mean the Llama and GPT base models, right? So there is a difference. Then we move on to supervised fine tuning. Now, contractors, real humans, write these question and answers. These are basically called prompts and responses because you prompt the model, right? These are basically low quantity and high quality, but these contractors are not domain specific contractors. These are just people who kind of write things online, right? So this is to train this GPT or any LLM how like what is the expectation of the user. So when I say, can you write me a poem about bread and cheese? This step will basically train GPT to do that, right? So basically, all of these three steps are doing one and the same thing. They are just improving the model and improving the model's instruction following capability. Again, the task is to predict the next token. And from this, we get a supervised fine-tuned model. It again takes 1 to 100 GPUs, depending on your model size and how fast you want to get there. And it takes days of training. Example could be Vicuna model, 13 billion parameter. And we can deploy this model, really. Then, reward modeling and reinforcement learning is basically, the contractors just kind of comparing outputs. Uh, I'm not sure, but I'm not sure, but you might have noticed that in ChatGPT, you get two responses and they prompt you to answer which one of these is better, right? So this is similar to reward modeling and reward reinforcement learning, wherein based on your feedback, they work on improving that model. One is automated. Reward modeling is automated. They have a binary classifier which does this work automatically based on a data set that is given. And in reinforcement learning, they basically have contractors do that work for them and select the best output of the one. Again, it takes 1 to 100 GPUs, and it really depends on you when you want to stop, right? There is no end to it. There is no end to find your. So this step is basically training, and all of these three steps are called like fine tuning a large language model. And after this reinforcement learning step, you finally get something like ChatGPT and even Anthropic's Claude model. Anthropic's Claude 3 is performing really well. So this is how you get that. Training data for these models are like very, very huge. Even these models are huge because ChatGPT uh, has 175 billion parameters, which is like a very huge model, right? And even the training data sets are very huge. Llama is a very small model as compared to ChatGPT. And even here you can see that their training data set is around 4.5 terabytes, if we estimate it roughly, right? Most of it is common crawl, which is basically, crawling through websites that are available. There is C4, GitHub, Wikipedia, Books, Archive, and Stack Exchange. And you can include a lot of other websites as well, other data sources as well, depending on your use case. Maybe you want to train a large language model specific for your organization. In that case, you will move on to procuring your documentation and all of that, uh, the data that is available. Well, to handle this very big model and this huge training set, even the infrastructure required is very, very large. This is an actual snapshot of Azure's data center for training GPT because GPT is hosted on Azure. And using InfiniBands, these server instances are connected at a network bandwidth of 3.6 terabyte per second. In layman's terms, it is 80 4K movies per second that you can download in there, right? When we talk about checkpoint, if you are familiar with machine learning, deep learning, you might have heard about checkpointing, right? So that you don't lose progress, you kind of make intermediate checkpoints, right? And even if you fine tune, you want to have multiple versions of that fine tuned model as checkpoint saved, right? ChatGPT takes around 1 terabyte of space just to save a checkpoint, right? And it takes 96 GPUs, and this is like uh, one GPU is like maybe 40 or 100 GBs of VRAM. And this is very huge and this is very costly to do. So they improvised and they had algorithms like LoRa, which is low rank adaptive fine tuning to do this, where only the parameters that are changing are saved. So now the checkpoint reduced from 1 terabyte to 200 MBs, and the GPUs used to do this reduced from 96 GPUs to 24 GPUs. And when they really kind of uh, analyzed the checkpoints, only 1% of the parameters were changing. So they only saved the deltas and not the real matrices saving all of those parameters, right? And to efficiently distribute this training of large language models, they use something called deep speed, which has a lot of options available, whether you want to do data parallel, as in like split your data into multiple GPUs, you want to offload your parameters onto CPUs so that all of the work is not done on GPUs because GPUs are costly to run, right? And they're costly to procure also. So you can use a combination of GPUs and CPUs to do this job for you. So using this, they kind of achieved training something like ChatGPT. And not only this, they even wrote their own programming language to optimize how they kind of train this large language model, which is called Triton. Uh, so I have two example models now. So GPT-3, which was released in 2020 and also is the backbone of ChatGPT right now, if you're not switching to GPT-4, they're using this ChatGPT-3 175 billion parameter model. And you can see that this batch size is 3.2 million text at one go. And as data scientist, I'm sure that you would use 5 or 10 uh, batch size, or even 16 to 32 if your data set is small and you have a large GPU to train this. But because they had so many GPUs available with them, they used this huge batch size because they also had to parse all of the training data set that they had available, right? Now, OpenAI did not release the specifications of the GPUs or time taken or the money spent, but they used V100 GPUs. The order is in 1,000 to 10,000. They just gave us a range that the maximum was 10,000 V100 GPUs at a time. They took like 1 month of training time to kind of train this fine tune, like the last three steps from what we saw. And it took 1 to 10 million. Again, a range was given to us. But Llama, which was open source from Meta, Facebook, they gave us the actual numbers. They used 2048 A100 GPUs. It took 21 days to train this model, and they spent $5 million to train this model, right? And you can see that this model is like half really of it, even less than a half of what the real model is. And they used a batch size of 4 million, even though, they had so many less parameters. We have leaderboards available for us if you want to try it out. So this leaderboard basically hosts a lot of these models, open source or proprietary, and you can go and compare. So there is LLMs actually hosts a very nice dashboard where you can uh, compare these models. It is called Chatbot Battle Arena if you are interested, and you can chat with and see which model is performing better. And they have this ELO rating, and a lot of open source data sets and benchmarks are there, which is used to compare the models. So you can go to these links, which are mentioned below, to compare these models very efficiently. Now let's move on to the architecture of ChatGPT. Like, what is the underlying architecture? Like each machine learning model, each deep learning model has an architecture below it. So let's move on to that and discuss that. So, in 2017, a research paper was released called Attention is All You Need. Well, no shit, right? Everyone needs attention. But they basically talked about giving attention to specific tokens. And this is, the paper that changed how we solve NLP problems. And from there onwards, we saw a huge boom in both applications of NLP and improvements in performance when you compared it to the open source data sets. On the left-hand side, this is how a normal feed-forward neural network looks like. And on the right-hand side, this is how a transformer, the architecture which Attention is All You Need paper proposed, looks like. This thing is this little blue box here, which is the feed-forward network. And the thing that really differentiates it from, all of the other deep learning models is the attention that is there. So this is the complete transformer which was proposed, but ChatGPT is a decoder only transformer, which means that only the right part is used. They discard the left part, and there are some models which use only the left part. This is called the encoder, and there are some models which use both, like encoder and decoder. So you can explore BERT, Roberta, and all of these other architectures of models. And I think Hugging Face should be your go-to library if you want to learn about it or train your own models, because they have created a very nice ecosystem of how you can interact with these models and train these models efficiently. If we talk about how these models really understand what we are saying to them, how they are understanding the natural language, they use something called a tokenizer, and OpenAI has hosted their tokenizer, wherein you can see how they are splitting the words and mapping them into IDs. Here I have deliberately made a mistake so that I can show how it is kind of tokenizing it. You can see that GOFT, because it is not a real word, it has split it into two parts, right? And rest all of these words are like individual tokens. And if I see, the IDs, I get a unique ID to each of this. right? So if I look at two words or two characters which are similar, I'll notice that they have a same ID, really, like 345 and 345 for I and I, right? Is there a question?
Drilling machine participate. Children said that.
I'm sorry, you're not really audible properly. Okay, I believe no question. Well, while pre-training, we discussed how these large language models aim and objective is to predict the next token, right? So if we demonstrate it, like if we break it down, this is how it looks like. Now we give it a context, the large language model, that this is the text that we have in hand. It could be the prompt or it could be a snippet from the text, right? And the task of this large language model is to predict the next token. And the way it does is that every model has a vocabulary with it, right? The vocabulary from which it can choose. That is the job of tokenizer to build this vocabulary because we will have a finite set of tokens, right? So once we have this context and we have a word, we will get a probability distribution stating out the probability of each of these tokens that we have available. And we will choose the highest one of it. It is pretty straightforward and it is pretty simple. So green is basically a random highlighted token. Yellow is basically its context and red is its target, right? So they have highlighted green to show how the probability looks like. And you can see here that only the decoder part of the transformer is used. So this is how basically the model functions. You get a probability distribution of 50,000 numbers, right? And you choose the highest ranking from it. And from the index, you map it back to the original word. This is 50,000 because the vocabulary of GPT-3 was 50,000 to 57, but each model can have a different vocabulary depending on what tokenizer you use. You can use a pre-trained tokenizer and you can even use or build, your own tokenizer. For example, you can choose to use GPT's tokenizer only since I've worked hard on building it. Well, I have told you about how big these models really are and how difficult it is for us to train them and use them. So we'll talk now about what can we do? Like what can we data scientists do? Because we do not have millions of dollars available with us unless we are working in very large corporations. If we are in a startup or a mid-sized company, we can get only $1,000 maybe as our allowance to work with large language models. Well, we have a couple of options available with us. One is that we can use these things like LoRa, QLoRa, to have efficient adapters so that we can load and fine tune these large models onto smaller GPUs. We can quantize these models. For example, like float basically takes 32 uh, bits of storage space, right? You can quantize it to use only 4 bits of information. Uh, we can move towards smaller models. Nano GPT is a very nice example if you want to understand how these large language model works. Karpathy has a very nice YouTube video where he talks about how a tokenizer is built and how a LLM is built, right? So you can go ahead and watch this. But for like a production use case, for something that you want to have customers interact with, you can use models like Phi from Microsoft, which are just like 1 billion to 3 billion parameter model, and you can even load them in your mobile phones, which is pretty cool. The third option, of course, is to use ChatGPT and Anthropic's Claude and other models that are really good, but use some tool like LangChain, which provides the relevant context to the model so that the model knows about what your domain is, and the model can leverage that information to formulate answers which are easy to consume by the users, right? So you can, in any case, redesign how the users interact with your content. Like you don't have to recommend articles. Now you can just give out answers for the queries that your users have. So I also got my hands dirty on training and fine-tuning models. So I have a couple of results. So this is a 10 million parameter model. Now notice that we were talking in like terms of billions. This is just a 10 million parameter model. And this is just 30 minutes of training. Now, again, like we were discussing how it takes months to train, and I just trained it for 30 minutes. So this model was trained on Shakespeare's data, and we can see that it is outputting Shakespeare's like text, right? All of the words are like from the Shakespeare's vocabulary only, but the story does not make any sense because it is just learning how to generate text right now. It is not learning how to formulate stories or how to give out answers if I ask it a question or I give it a prompt that write a story about this or tell me about this incident from Shakespeare's text, right? On the downside, I have a 3 billion parameter model. And again, I have, the examples from it. In just 1 hour of training, like I asked it how to make a lemon pie. And you can see that, it has already started to learn how a lemon pie is made, and it was able to understand what my question was, and it does not have to give me with more questions, it has to give me with a response, right? So it basically said the steps for making a lemon herringuid pie include making the crust, preparing lemon fills, creating the ingredient, and baking the pie. Finally, the pie should if baskets and garnished with lemon simplest, right? Now, of course, this recipe is not perfect, but we are progressing towards there. If I keep on training this model, I'm sure that we'll get there, right? And remember that this is just a 3 billion parameter model with no quantization, no adapters used in this, and nothing. Well, with this, with the research that is going on, now you can train a 20 billion parameter model on a free Google Colab instance also. If you want to try it out, you can use LoRa and QLoRa adapters to fine tune these models. You can quantize that model. I think Rope and Alibi, these are some things that some researchers that are done. You can leverage those. Rope is for rotatory positional embeddings and Alibi is for attention with linear biases. And finally, you can leverage, services like Unsloth or even, I'm sorry, I'm missing on that. But there is another service that you can leverage to train these models really fast for you, right? And using very limited computational resources. So this is an example of how I have trained a model using QLoRa on a free Google Colab instance. I loaded the model, I gave it a text. Now this is again a base model. This is not an instruction find tune model. But you can do it, right? It is pretty simple to do it using the Hugging Face ecosystem. And if you'll explore, you will get to know that it is pretty simple. I gave it like, hello, my name is as the prompt. And max new tokens is something that we can define. If you use the ChatGPT's API, you'll notice that they also have a max tokens to generate. And the maximum value allowed is 4096. And you can even set it to 5, 10, 20, whatever you want to, right? This is basically used to control the costing of the model. And it was able to generate 20 more tokens. And it finally generated that, hello, my name is John. And I'm a student at the University of Phoenix. I'm a member of, and it is cut off here. So this is where the fine tuning comes into picture, wherein using that reinforcement learning and that reward modeling, you teach it to end the sentences based on the number of tokens that are allowed, right? In ChatGPT, if you ask it, write 10 lines about the specific topics, it will write exactly 10 lines, right? If you ask it, give me in 10 words a definition of maybe LLM, it will in exactly 10 words give you a definition of LLM, right? So that is how you incrementally start to train it. And that is why it is so costly to train. And it takes so much time and resources to train, right? Well, if we ask this question to ourselves, if these models are good, well, the simple answer is no, because I asked it what is 2 plus 3 plus 5, and it gave me that the result of 5 plus 3 is 8, and 2 plus 3 is 5, so the sum of all numbers is also 8, which is not correct, right? But these models are really good at generating text. So if you have a use case where you just have to interact with users, answer their queries using some base documents, you can really use these models. For example, I asked it, a llama entered in my garden, what should I do? And I specifically asked about llama because llama is also a model given out by Meta Facebook, right? So I wanted to see if this LLM will confuse between llama as a model and llama as an animal, but it was able to capture exactly what I was asking, and the answer that is given also makes sense. Okay. Is there a question?
Chit, I think you can continue.
Okay. Thanks, ma'am. So if you look at the answer, it actually makes sense and it is really nice. All of the grammar is correct, the punctuation is correct, spellings are correct, right? So this is how the models perform. This is, by the way, Quangpo 34 billion parameter model. And you do not have to go towards 34 billion parameter model or a large model to get performance. Yes, it does make a difference, but with the release of Llama, smaller Llama models, and even 5.3, which was recently released, we have now started to notice that, it is really the training data set quality that makes a difference, and not just the number of parameters that your model has or how big your model is, right? So you have to consider a lot of things when you are choosing a model for your specific use case. Well, to solve this problem of getting wrong answers, we again have solutions with us available. So the first one is to use effective prompt engineering techniques. So one is to just give input and output, right? You give it a prompt, you give it a question, and you'll get an answer. The next one, and which is most commonly used, is to give chain of thought, right? Allowing LLM to question itself and, giving it more time to think, asking it to reason the answers that it is giving. And the third one is to use self-consistency. These are like all prompt engineering techniques, and there are a lot of techniques like this. There is promptengineeringguide.ai, I believe, a website that hosts all of these techniques very nicely and has very nice documentations if you want to learn about it. Tree of Thoughts obviously gives the best results out of all of these, but like it takes a lot of time, right? Because a lot of call goes to the LLM because it is really a tree of decisions that are uh, giving you the final answer. For example, I give it an input. I will give that input to three LLMs. If not three LLMs, give it to the LLM three times with different temperature and different parameters. With the output, with the highest probability, I move to the next step and, so on. I proceed towards the final answer that is available. The next solution is to use something called LangChain. You have your documents ready, right? It could be PDF, it could be video, depending on how you want to pass it, right? The important bit is that you should be able to extract the text out of it. Even if it is a YouTube video, you should be able to get the transcription out of it because large language models currently understand only text, but there are multi-model also available now. Like GPT-4 now has vision capabilities also. You can give it an image and it will understand what that image is. Or uh, GPT-4 has even demonstrated very good text extraction capabilities from the documents that you give it, right? So you have to get the text out of it. Then you can use a vector store. For example, there is Llama Index. Mongo also has that. Amazon, Elasticsearch. There is OpenSearch available from Amazon, right? There is Pinecone, a lot of vector stores depending on your use case, your specific use case, and your budget allowance. You can choose any one of those vector stores. This vector store is basically to retrieve the relevant context. For example, if I ask it, who is Anchit, right? I want only the documents that are related to Anchit to go in as context to these large language models. Because these models have limited context, right? I cannot give it all of the information in the world and expect it to answer, right? Because that will require huge systems to process that information. So basically, to rank these documents, depending on your query, uh, we use vector stores to efficiently retrieve and then supply it to uh, the large language model. And then LangChain is used kind of a tool to map these documents that are extracted and then sending it to the large language model. And also LangChain has a very nice ecosystem available for you to parse documents. There are PDF parsers, CSV parsers, Excel parsers, database parsers, and whatnot. And they even have prompt engineering templates available, right? So you can use chain of thought or tree of thought or, self-consistency right off of the box uh, by just calling a function that is already available in LangChain. And using this, finally, you get your final answer. The third option available is, of course, to fine tune these models based on your use case. For example, if I want the model to solve only mathematical problems, I will gather or collect some, data set for mathematical question answering. And then I'll fine tune the model to solve those specific use cases. And, there is an improvement in performance, but there is always a fear of hallucination within the model. So you have to use something like guardrail to check the output, like if the output is correct or if it is hallucinating, right? Uh, you can use services to kind of check what is the tone of the answer that is given to prevent from harmful answers going out to the customers, right? Because these large language models can learn anything. The data set is so huge. I'm sure there is some harmful content also there. So you have to be extra careful about what harmful information your model is answering and how you can control it, right? So this is an example of standard prompting versus chain of thought prompting. So on the left-hand side, I have the model input. I gave it a question and an example. So this is called few shot prompting, basically, wherein I give it a few shots, like a few examples for it to kind of understand how exactly it has to solve the problem. And then when I gave it a question, it assumed that its task is to generate a random number, and it gave the answer to be 27, which is not really the right answer, right? So the correct way to solve these sort of problems is to kind of explain and prompt this LLM to solve it step by step, right? So this reduces the chances of this LLM to hallucinate and give you wrong answers. So again, the same question, but this time, along with the answer, I give it a few steps of how it can solve this problem. And you can see that it explained and also gave the correct answer as the output, right? So this is how you can basically improve the performance of this model. Well, a high-level structure of LangChain is as follows. Well, you can use any LLM, be it OpenAI's LLM that are available, right? Hugging Face open source models that are hosted there. You can use Anthropic's Claude or, really any LLM that is there in the world. For memory, you can use a lot of memory types that are available. For example, you can use simple memory, which takes the 5 previous conversations into account. You can use vector store backed memory, which basically retrieves the relevant memory based on the prompt that is given by the user. And there are a lot of other types of memories also. For prompts, you can choose any prompt engineering template that is available, or you can even create your own prompt in LangChain. And you can use agents. For example, I want to connect my LLM with weather data or, news API, right? I can do that. I can have agents available with me. So in that case, while reasoning, the LLM will prompt that I want to leverage the news API or the weather API. You will call that API in the backend, give the results to the LLM, and while the LLM is giving out the final answer, it will include that information in the answer, right? So this way you can now have weather news or and like any service that you want to integrate. If you go to the new IRCTC website, Indian Railways ticket booking website, you'll notice that they have done some serious improvements to the chatbot that is there, and now you can talk to it in natural language, and it will help you with bookings and pulling out relevant train informations and available tickets, plan out your journey, and a lot of different things, right? It is called LangChain because you chain all of these features that are available into a final chain, and you can have some uh, end use cases. For example, you can have it to have question answering over documents. Uh, you can have it for summarization of documents. You can use it to create chatbots. You can query tabular data. You can interact with APIs, and you can even use it for code understanding. I think almost all of you might have heard about Devin AI. It is also a large language model which was basically set to replace developers. Even GitHub's Copilot is an LLM, which basically leverages these tools to generate text for you and help you while you're coding, right? And like we already saw a demo of how I leveraged ChatGPT to understand the code snippet that I had available with me. This is that image enlarged. Like I think we have already discussed it. One important piece that I missed out in the previous slide was that we should have text embeddings also available with us so that we can rank these text in an efficient manner. So when Elastic was released, and initially Google used to do query-based searching, right? So for example, if I ask, Chinese restaurants near me, it would pick up things like restaurant near me and it would do a query search over all of the documents, Even if I ask like, is this restaurant good? There were high chances that it gave me results with some restaurant with, a website with just restaurant mentions and not actually any reviews of it. So by using text embeddings, we are also able to capture the context of the query and we are able to rank these documents based on what type of question we are asking. So now if I ask it, give me some restaurants and give me some restaurant reviews, we will be efficiently able to differentiate between these two queries, right? So having these text embeddings are really important for your document retrieval. You can, of course, depend solely on keyword-based searching, which is available in Elasticsearch. But a good thing to have is to do semantic search using embeddings also. So this embedding model is from OpenAI, again, a proprietary model, but you can use open source models that are available also to do this job for you. Well, that is all that I have to share with you guys. I will stop now for questions if there are any.
Hey, Anchit, hi. So I have a question.
Hey, man.
Hey, hi. Am I audible?
Yeah, you are.
So I had a question that so you were giving an example where you trained the model and of around 10 million parameters, if I'm not wrong.
Mhm.
And so basically, was it pre-trained? Like, were you using Llama or some similar kind of model for,
No,
and you just fine-tuned it on your data?
no, it was basically pre-training only. So it was a model that I built from scratch using just the architecture. I was
Okay.
not using any backbone, and
Okay.
using that, I trained it on Shakespeare's data, and it was only trained on Shakespeare's data, given the small size of that model.
Oh, that's so you like wrote the whole sort of model from scratch, if I'm
Y-
getting it
Yeah,
correctly.
all of that mathematical calculations and everything.
That's pretty cool.
Thank you.
Yeah, yeah.
Well,
Also,
Karpati has a very nice video of this building GPT from scratch. You should check it out. And, he really
right,
teaches you to do this stuff.
right. Yeah, watching the videos and implementing are two like all different ball games. Uh, but yeah, definitely commendable. Uh, Also, one more thing, like what was the data size that you used for building for the training here?
It was just 3 MBs of plain text files, which is huge. Like 3 MBs is a lot, considering it
Uh-huh.
was a TXT file. Uh, but like it was just 3 MBs.
Okay. And the
My
machine that you
entire
used for
system.
the same?
So it was RTX 3060 Ti,
Okay.
and it scaled up to like 4 GBs of maximum consumption without quantization and without any optimizations available.
Okay, got it. Thanks, man.
Thank you.
Yeah. Hey, hi, Anchit. So, in the continuation of the discussion, so
Mhm.
it is that code is available on your GitHub, or like have you put it in at some open source, or I mean, have
Yes.
you put it?
Yeah, it is available on my GitHub. I'll just share that link. But I sincerely want you guys to check out Karpathi's implementation because
Mhm.
that is much better and optimized. But sure, I'll share my implementation as well.
Yeah, thank you. And apart from it, it's like I have one like a doubt in my mind that usually these chat GPTs are not able to answer for for the live things which are happening. So
Mhm.
for example, let's just say anything like which is happening around the world, and if I put that I want the information about it, which
Mhm.
just happened, let's say 2 days ago or 3 days ago or a week ago. So
Right.
it really gives a message that of course, for those events, these models are not trained yet. But do you think that there would be something in the future, which will just gives us the information about these the current events as well? I mean, it would be like the training is continuously happening uh, uh, for the new content which is coming on the internet, and these models are giving us the answers.
Well, you don't have to wait for future because it is already there. So along with these large language models, because they was trained on static data, you can leverage something called tools and agents, right? So I
Yeah.
can connect it with, for example, Google Search API, right? So
Mhm.
each time I write a query now, it will do a Google search. Now, this is kind of a multi-step process wherein the agent is also given a scratch pad to kind of gather its thoughts. Uh, from the Google search results, it will then start to compile an answer, and you'll get details of the most recent issues as well. I think the Twitter's Grok model, which they recently released, has this capability where it is able to consume all of the Twitter information in real time.
Mm-hmm.
So I suggest that you start reading about RAG, retrieval, augmentation, and generation. Uh,
Mm-hmm.
so these pipelines can help you to solve those issues.
Mm-hmm. Okay.
I think even GPT-4 is also connected to web server.
Yep. GPT-4 is connected, but you have to opt for a different plan. Like it is not always kind of uh,
Yeah.
like there are multiple options that are available, right? There is GPT-4 without vision, with vision, and there is one with external API connectors. So you have to specifically opt in for that if you want to try it out.
Okay. Okay, fine. I'll check it out. Thank you.
Yep. Thank you. There is a question from Jobanpreet. Uh, okay. So Jobanpreet, I think your first kind of go-to thing should be to check if there is any model available, any multi-model model available which supports Punjabi, right? And then you can start to fine tune on it because training a model from scratch will definitely take a lot of resources and money. But if you want to get an estimate on how much data is required, I suggest that you go through OpenAI's paper on chinchilla laws of scaling. So chinchilla is a model that they train to kind of solely experiment with how much data is required to train a model and how much information is stored by a model. So that will give you a good idea of how much training data you require, how much synthetic data you need to add. That is changing with the release of these new flash attention and all of this. But still, that research paper should be a starting point, and it will give you all of the information. Because if I start to answer, this will another be in another 1 hour session. But let me know. Drop me an email, and we can discuss this further in detail. Any more questions?
Hi, Anchit. So, question that how is job market for data science going to change with the new LLMs coming?
Right. Well, with the release of Devin AI, I'm sure that you've also seen that video and that is why you're scared. But I feel that there should always be a human in loop. So if you are a data scientist that is up to date with these latest tools and technologies, there is a huge scope because almost every startup wants to get into AI, LLMs. So if you are able to write effective prompts, if you are able to kind of fine tune these models, leveraging flash attention and all of this, uh, then there is a huge market available for you.
Yeah, agree. Thank you.
Vikas asks, I want to build a chatbot for XYZ organization, for example, IRCTC. You mentioned what steps for that. Okay. So Vikas, first of all, based on your use case, you will choose a model, an open source model. For example, if not proprietary, if you are kind of scared to upload your documents onto third-party servers. So there are a lot of benchmarks available, right? So for example, if you want a model that is good at reasoning, you will look for models ranked by that specific benchmark that is available. Once you have chosen this model with you, you will decide on the features and what agents you want to connect to it, right? And I suggest that you use pre-trained or even like instruction fine-tuned models for your use case so that you can skip all of these steps as well. Um, Now, chances are that your model will start to perform well right out of the box if you are able to give it the right context. But if required, you can fine tune it only on that specific small set of instructions and responses for your use case. So, for example, if I use Llama instruct based, which is already trained on a lot of instruction following datasets that are available, I only have to train it using, for example, just 1,000 rows of instructions for my specific organization, and I'll get a good model. The key to using LLMs is to have effective guardrails and RAG pipelines available with you. All right, thank you. Okay. So for learning this, I suggest that you go to Hugging Face. They have a very nice documentation where they walk you through all of these implementations step by step. Now again, uh, if you want to watch some YouTube videos, I believe Syntex has a very nice playlist where he shows how you can fine tune large language models. So I think these two should be enough for you to get going. Okay, so Manish is asking how we can make it fast and how we can optimize. So Manish, like there are some solutions available for that as well. One solution to make it fast is to use something called flash attention. So very interesting research paper if you go through it. They basically kind of optimized how mathematical calculations are done on the physical GPU hardware. So instead of storing everything on uh, HGB RAM, I believe that is what it is called. They started to do calculations, break it down and do calculations on the SVRAM, which is much more faster. So one is that to make it fast. So you can just use flash attention and flash attention 2. The other is to use some low level language so that you can remove this Python wrapper. For example, you can write all of your code in C++. And the other solution could be to use a mixture of model approach. For example, you have a model with 540 billion parameters, and you do not want to have all of those 540 billion parameters loaded and used when you want to have inference. You can divide those 540 into 54 billion 10 models, right? And based on that, you can direct uh, to which model you want to answer. What if we try to make a GUI interface for it to be in the webinar? If you want to create GUI, I think the first go-to solution for data scientists is to use Gradio, like Gradio and Streamlit. These are the two things that data scientists go to because you can create applications in Python. If you do not want to do that, I think there is Langflow, which gives you an interactive uh, sort of web UI to connect all of these agents using a flowchart, drag and drop, and all of that. So you can leverage that as well. Any more questions, guys?
So we have another question for Anchit. I think Anchit, we can wind up the session then if we do not have any question.
All
Anchit,
right.
it would be great if you please turn on your camera for a while.
Unfortunately, I broke my laptop, so
Oh, okay, fine. Okay. So, Priyanka, are you there?
Yeah.
One more question there in the chat, Anchit.
Yeah. So like to build chatbot similar to that, I think you can explore fine-tuning your large language model or have RAG pipelines. I think the simplest way to build this sort of chatbot is to use OpenAI or Anthropic APIs so that you can leverage GPT-3, GPT-4, and Claude models to have these applications up and running in no time for you. I suggest that all of you go through RAG pipelines, what they are and how we can leverage that, because that is something that will really change how we interact with large language models. Thank you everyone for sparing your time this Saturday evening to join this session with me, and I hope you were able to learn from this.
Thank you, Anshul. Thank you to the interns for the interactive session. We'll share a feedback form in the chat and we encourage you to respond to it. Shukila ma'am, can you please?
Yes, Priyanka. Okay, so do you want me to share? Just a minute.
Sure, ma'am. Thank you.
Priyanka, I'm not able to share. Just a minute. Okay. Yes. So, feedback form is there in your chat. Please, everyone, fill the feedback form. Thank you so much, Anchit, to be there. Thank you. It was lovely hearing you, Anchit.
My pleasure, ma'am. Thank you very much for having me.
Thank you.
All right. Good day, everyone. Bye bye.